Welcome to EDU World Space.
So in this problem, we are given with a combustion reaction of octane, which occurs like this. So we are writing the balanced equation of the combustion of octane. You write C8H18 in liquid form will react with 25 oxygen molecule in gas form and will produce 16 carbon dioxide and 18 water vapor. Now, first question here is how many moles of O2 are needed to burn 1.5 mole of C8H18? So from here we can see that 2 mole of octane, since we have a coefficient of 2 here, we can see that 2 mole of octane is burned by 25 mole of oxygen. So we can write 2 mole C8H18 is burned by 25 mole O2. That means 1.5 mole of octane will be burned by 25 over 2 times 1.5 mole, which will give us a value of 18.75 mole O2. So 18.75 mole O2 is required to burn 1.5 mole octane. Now in the second part of this problem, we are asked how many grams of O2 are needed to burn 10 gram of octane. So as we know that from the reaction equation, we have to deal with the number of moles of each reactant or product. That means if we are given any reactant or product in mass, then we have first thing we have to do is we have to convert the mass into number of moles. So we are given 10 gram of octane. That means we have to find out the number of moles of 10 gram of octane. So and we know that the number of moles is mass over molar mass. So 10 gram octane means 10 gram over the molar mass of octane, which is 114 gram per mole, and this will give us a value of 0.088 mole. So this is the number of mole of octane for 10 gram of octane. And now we have to find out how many moles of oxygen is needed to burn this much mole of octane. And from that number of mole of oxygen, we can find out how many grams of oxygen we need to burn 10 gram of octane. Now again, we have seen that 2 mole of octane is burned by 25 mole oxygen. That means 0.088 mole octane will be burned by 25 by 2 times 0.088 mole, which will give us a value of 1.096 mole O2. So 1.096 mole O2 is required to burn 0.088 mole octane. And again, we can find out the mass of oxygen for this number of mole of oxygen, which is simply we have to multiply this number of mole by the molar mass of oxygen. So mass of oxygen is 1.096 mole times the molar mass of oxygen, which is 32, since we have oxygen molecule here, and this will give us a value of 35.1 gram. So this is the mass of oxygen which is required to burn 10 gram of octane. Now in the third part we are given the density of octane, and we have to find out how many grams of oxygen required to burn 15 gallon of octane. Same thing, we have to first convert this gallon to number of moles, and then we have to find out how many moles of oxygen we need to burn that many moles of octane. And from there, from the number of moles of oxygen, we can find the gram of oxygen required to burn the 15 gallon of octane. So first, we can convert the gallon to the milliliter. Since the density is given in gram per milliliter, we have to find out how many milliliters are in 15 gallon. So 15 gallon, um, so 1 gallon is 3785 milliliter. That means 15 gallon means 15 gallon times 3785, 15 times 3785 ml. It will give us a value of 5.68 times 10 to the power 4 milliliter. So this is the, or you can write it ml per gallon and 15 gallon. So 5.6 is time 10 to the power 4 ml is the volume for 15 gallon. Now, as we know that we're given the density of octane, and now we have find out the volume of octane. And if we just multiply density by volume, we can find the mass of 15 gallon octane. So the mass is volume times density. Volume here is 5.68 times 10 to the power 4 ml, and the density is given as 0.692 gram per ml. And from here the value will be 3.93 times 10 to the power 4 gram octane. So this is the mass of octane for 15 gallon octane. Now we know the mass. So from the mass we can find out the number of moles of octane. So the number of moles of octane is now its mass over molar mass. So 3.93 times 10 to the power 4 gram over the molar mass of octane, which is 114 gram per mole, and this will give us a value of 345 mole of octane. So you have to find out how many mole of oxygen we need to burn 345 mole of octane. Now we have already seen that 2 mole of octane is burned by 25 mole oxygen. That means 345 mole octane will be burned by 25 over 2 times 345 mole, which is equal to 4312.5 mole of oxygen. And now we can just convert this mole to mass to get the mass of oxygen. So 4312.5 mole times the molar mass of oxygen molecule, which is 32 gram per mole, and this will give us a value of 1.38 times 10 cube gram oxygen. So this is the mass of oxygen which is required to burn 15 gallon of octane. Now in the last part of this problem, we have to find out how many grams of CO2 are produced when 15 gallon of C8H18 are combusted. So as I've already said, whatever quantity we are given, we have to um, convert everything into number of moles to find out how many moles of other reactant or product is required or produced. So once again, we have to find out the number of moles for 15 gallon of octane, and what we have already done. So here we have find out, so this is the number of mole of 15 gallon octane. So we know that 345 mole of octane. So we have to find out how many mole of carbon dioxide is produced per 345 mole of octane, and from there we can find out um, how many grams of CO2 is produced from 345 mole of octane. So we go back to the main reaction equation again. So here we can see that for 2 mole of octane we can have 16 mole of CO2. That means we can write 2 mole octane can produce 16 mole CO2. That means 345 mole octane will produce 16 over 2 times 345 mole CO2, which will give us of 2760 mole CO2. And if we just multiply this by the molar mass of CO2, which is 44.01 gram per mole, it will give us the mass of CO2, which is 1.21 times 10 to the power 5 gram CO2. So 1.21 times 10 to the power 5 gram of CO2 is required or is produced when 15 gallon of octane are combusted.